Okay, let us start, everyone. Last day we were discussing number theory. Let me see. I hope everyone can see my screen. Okay, these were the homework questions. Okay, I'm going to write down the answers. Okay, you people got 120 minutes over here. Tell me, what did you get? Sorry, 120 seconds means 2 minutes. You people got 2 minutes? Tell me. Anyone having any doubt, you can ask me. I'll explain. Tell me. First one, everyone got 2 minutes. Next.
Yes, sir.
Over here, 16 times.
Sir, 15 times.
Why 15? Should be 16 times, right?
Yes, sir.
How it is 16 times, I'm telling you, Abhiraj. You must have divided 30 by 215, isn't it? But try to understand. You have to count the first bell also, right?
Oh,
Are getting? You have to count the first bell also. Next. Third one, you people got 15 pairs. How much? 15 pairs, everyone?
sir, I got 15 pairs.
Yes, 15 pairs. Very easy. Anyone having any doubt, you can ask me. Next, fine.
Sir, if we count the reverse factors also, then I'm getting 30 plus.
If we count,
Like if we count 1 and 30 and 30 comma 1, if we
no,
count these as two factors.
whenever they are talking about pairs, okay, we are talking about distinct pairs, okay? Are getting ordered pairs. They are talking about ordered pairs.
Yes,
Understood?
yes.
Find the number of even factors. Even factors, did you people get 24? Tell me how much you got.
24.
Everyone?
Yes, sir,
24.
24.
Then
Yes.
24. 24 is correct. 24 is correct. And the last one is 15. Last one came in PRMO. I guess 2012 or 2013, probably.
Question number 4.
Question number 4, you have a doubt. Okay, let us start. Okay. Pn is equal to n plus 1. So this problem can be done verbally. Okay, everyone. This problem can be done verbally. Don't have to think much. You see, it's a product of all integers. It's a product of all integers. Okay, where there is a difference of 2. Can you understand? Aviraj? Product of all integers where there is a difference of 2. If n equal to 1, all the numbers are even. The product of 5 consecutive even natural numbers. If n equal to 2, the product is odd. Okay. Now, if it is product of even natural numbers, okay, that is fine. That we can calculate. It will be divisible by 5 factorial at least. Are you getting? Means product of 5 even natural numbers. I'm telling you one instance. 4, 6, 8, 10, 12. Okay, these are the product of consecutive even natural numbers. Okay. So over here, if you take 2 common, you'll get 2 into 2 to the power 5 common, you'll get 2 into 3 into 4 into 5 into 6. Okay, this is the product of 5 consecutive even natural numbers. It is divisible by 5 factorial. Okay, that is fine. Even natural numbers, that is okay. Okay, over there we can get 5 factorial. Let us talk about the case when all of them are odd. Okay, if all of them are odd, you are getting 3 consecutive. You are getting means it is not divisible by even natural numbers. Okay, now product of 5 consecutive odd natural numbers. At least one of the natural number, at least one of the number will be divisible by 5, right or not? At least one of n plus 1, n plus 3, or up to n plus 9 is divisible by 5. Yes or no? Tell me.
Yes, sir.
Yes, sir. 15 is a common divisor.
Yes. And at least one of them will be divisible by 3 as well. Right. So can I say that Pn is definitely divisible by 50? Hence the answer is 15. Is it clear?
What is the need of divisible by 5 and 3, sir?
If the number is divisible by 5 and the number is divisible by 3, so the number is divisible by 15 as well. Right or no?
So how are finding it is divisible by means how are they why are they taking as 5 as means why?
We are talking only about odd natural numbers. So I'm thinking only about odd natural numbers. First of all, I check whether it is divisible by 3 or 5 or not. Okay. It is divisible by 3. It is divisible by 5. So it is divisible by 15. Let's check for 7. For 7, will it be possible? Tell me.
Because it is not divisible by 5.
No. Think like this. Try to understand. Let us take one of them as 7. Okay. But the in case of 7, what will happen? We need 2 consecutive odd divisor or odd multiple of 7. 2 consecutive odd multiple of 7. Okay. Like for example, if you are taking 7 into 1, you must take 7 into 3. Means between 7 into 1 and 7 into 3, how many odd natural numbers are you getting? Tell me, consecutive.
Means 14.
14 odd natural numbers. Wait. Start with 9. You must get 9 to
Sorry.
19. Right.
Yes.
9 to 19. How many odd natural numbers are there? 10. How it is 10? No, it's not 10.
No, sir, it's I think, sir, you didn't take 20.
There are how many odd natural numbers?
Odd natural, sorry, odd 9, 11, 12.
6, right?
Yes,
Tell me.
yes.
So we are getting a contradiction that it is not divisible by 7. Are you getting? You will get at least one value of n such that this Pn is not divisible by 7. Are you getting my point?
Yes.
What I am trying to say. Okay. So 7 is not possible. So similarly 9 is also not possible. 11 is also not possible. And other odd natural numbers are also not possible. So Pn is definitely divisible by 3 and 5 for whatever value of n you take. Are you getting? Hence Pn is definitely divisible by 15. Tell me, is it clear, Aviraj? If you cannot understand, you ask me again. I'll explain.
Sir, my only, sir, I am getting out that, sir, means you are taking, sir, they have not given largest, showing the other question, sir, largest that is divisible by of Pn for all the positive integers. They have not told that is divisible by 3 or 5. So
No, they have not told, but we have found it. Forgetting. They have not told, but we'll find it, right? Means this should be valid for all n belongs to natural number. It shouldn't be valid for any particular value of n. It should be valid for all n belongs to natural number. Understood? For all n belongs to natural number, this Pn will be definitely divisible by 15. Definitely, because Pn will be definitely divisible by 3 for every value of n. Pn will be definitely divisible by 5 for every value of n. So Pn is divisible by 15. That is the largest possible value of largest possible divisor. Is it clear, Aviraj? Or should I explain again? Tell me.
No.
Understood? Okay, so everyone, let us there. Okay, let us start. Last day we have done HCF LCM. Okay, let us do one problem on HCF LCM. IOQM mock test also I start. Okay, but I'm thinking of taking IOQM mock test only offline because exam will be offline only. Okay, let's see. First of all, I'm thinking of chapter wise test. Question number 1. It is known that 2726 4472 5054 and 6412 have the same remainder. Find when they are divided by by some 2-digit natural number, some 2-digit natural number and find the value of n. Try this out. Okay, should I start, everyone? Let us start.
Sir,
Sir,
can you wait a minute?
Okay. Solve quickly. After this, we have to start with congruences and its properties. Already, I think I've done congruences. I did properties with everyone except with you, Avraj. Okay. So I'll just discuss a little bit. It's not congruency of triangles. It's congruences of number theory. Okay. We'll discuss. Okay, we'll discuss. Okay, a little part is required only. Okay, not completely. So once you've done it, send your answers, everyone.
Sir, I've done it. I'm sending.
Okay. Okay, so Ahir is sent. Let's see. Your
Sir,
answer is yes. I'm checking. Yes. Ahir, your answer is correct. And okay, yes, your answer.
Sir, when will you be taking the IOQM mock test?
Let's see. I'm planning very soon. I have the papers already with me.
Sir,
Okay.
can you take it like if offline, can you take it on weekdays?
Weekdays.
Yes, sir.
Wait, I'll give flexible slots for everyone. Okay.
so will you
But
keep time slots like the previous year? Like,
flexible slots. Like last year, I used to take mock test. Do you remember? The flexible slots.
yes, sir, yes, sir.
But for you people, the day of whenever you people are coming for the class, then only I'll take. Okay, so that it will be comfortable for you people.
Oh, okay. So after like 4 o'clock.
After 4 o'clock. Same with Venkat, Avijoy, and Arush as well. Arush, are you there?
Yes, sir.
Okay. Try this out. Okay, Venkat has sent. Yes, Venkat, your answer is correct.
Okay, sir.
Nilanjan, your answer is correct. Okay, let me start. So over here, it is known that 2726, 4472, 5054, and 6412 have the same remainder. Okay, so we know that we know how we used to calculate HCF by difference method, right? So over here, I'll find out the differences between the numbers. Okay, let us find out the differences between the numbers. Let's see. Okay, means the HCF will also divide their differences as well. Okay, see, those who don't know, don't remember this property. I think everyone knows, okay, but still, those who don't know, pay attention. For example, if HCF of A and B is equal to D, right? So can I say that A is equal to KD and B is equal to LD, right? So their difference, if I take the difference of A minus B is still divisible by D, right or not? A minus B is still divisible by D. Can you understand? Yes or no? Aviraj? Okay. So that is what I'm going to use over here. Okay. So can I say, now see, M divides the difference of these two numbers. Okay. Right. So can I say that M divides 2726, I mean 4472 minus 2726? Tell me. This implies M divides how much? What is the difference? You people must have calculated, right? Tell me. 4472 minus 2726. Tell me. Those have got the difference. How much you people got?
Sir, 1746.
1746. Correct. 1746. Okay. M also divides. M also divides the difference of 5054 and 4472. Tell me. Right, Arush, Avijoy, Venkat. I have done this in your class as well, right? Do you people
Yes, sir.
remember?
Yes, sir. Yes, sir.
So when we take the difference, what is the difference, everyone? You people got 582? Tell me. And M also divides. And M also divides. 5054 minus 2726. How much will it give us? Wait a minute. 6412. 6412 minus 5054. What does it imply?
1358.
1358. Correct. Now see, in order to get your answer very quickly, okay, you know that M is a 2-digit number. Okay, so in order to get your answer very quickly, you factorize the smallest of them. Are getting? Because your M is hidden in these differences only. Are getting? M divides all the three numbers. That means your M is hidden in these three numbers only. So you factorize the smallest of them. Okay, let us factorize. Actually, you have to factorize all three, but in order to get your answer quickly, you factorize the smallest of them and check with the others. Are you getting?
The logic behind this words that we are doing the smallest. What is the logic?
See, there is a number that divides all the three numbers.
Yes, sir.
That means it is a common factor of all the three numbers, na?
Yes, sir.
Are you getting?
Yes, sir.
So I have to factorize all three of them. But instead of factorizing all three of them, I am factorizing the smaller one, and I check with all three of them whether it works or not. Are you getting? So that our task is quicker. Okay. I mean I have to save my time also in during the exam, na? So 582 you factorize, what will you get? 2 times 582 is equal to 2 times how much? 291. Right, 291 is divisible by 3. So 2 into 3 into 97. Okay. From here we can conclude that 97 is the only 2-digit number, right? Which is a factor of 582. That means my probable answer is 97. Okay, that is my probable answer. Okay, probable. I mean that is the only answer possible. Yes, that is the only 2-digit natural number which is a common factor, right? So you can directly write down the answer as m equal to 97. Are you getting? You don't even have to check. Okay, but still, if you feel that you might have done some mistake or something, then you just divide other numbers also by 97. Okay, I think it will be divisible. Understood my point? If you are having any doubt, let me know. I'll explain. Okay, those are online. Is it clear? Okay, next. Last day I had discussed about division algorithm. I'm just going to discuss how we can find out the HCF using Euclid's division algorithm. Okay, HCF by Euclid's division algorithm. Let us start. Okay, so everyone, to find HCF of, let us take two numbers. I'm taking 455 and 42. 455 and 42. Okay, what do we used to do? We prime factorize. Okay, but there is also another method, long division method. Do people remember long division method? Right? So what I'm going to do is I'm going to write down division algorithm over and over again. Okay, so this will give us 455 is equal to 42 into 10 plus 35. Right, tell me. Are you getting Aviraj?
Yes, sir.
And from here we can see that 42. Now see, 42 will become the dividend and 35 will become the divisor. So I can write 42 is equal to 35 into 1 plus 7. Okay, sorry, 35 into 1 plus 7, and then 35 we can write it as 7 into 5 plus 0. So as soon as you get 0, the divisor becomes the HCF. Therefore, HCF is equal to 35. No, 7. Why 35? 7. Okay. Now, do you remember last day I had taught you one property of HCF?
Yes, sir.
That is GCD of AB is equal to G. There exists some integers x and y such that ax plus by is equal to G. See how we can find out those how we can find out x and y such that ax plus by is equal to G. Okay. So what you do is you start with the second last place. Okay, that is 7. Can I write 7 is equal to 42 minus 35 into 1? Tell me, Aviraj, are you getting?
Yes, sir.
Yes. From the second step. Now you look at the previous step. In the previous step, you have 35. Your task is to always keep on replacing the remainders. Okay. Next. Now 35 can be replaced by 455 minus 42 into 10. Right. So this will become 42 minus 455 minus 42 into 10. Okay. When you open the brackets, this will become 42 minus 455 plus 42 into 10. Right. Tell me, are you getting average?
Yes,
So this will become 42 into 11 minus 455. This will become 42 into 11 plus 455 into minus 1. So what are the integers? Integers are 11 and minus 1. Therefore x is equal to 11 and y is equal to minus 1. Okay. Tell me, Avraj, if you have a doubt, you ask me. I'll explain. Understood? Very easy.
Sir, can you just once and can you do upset? I want to just see, sir.
Yes, tell me.
And I want to just see, sir, what it is.
See properly. Is it done?
Yes, sir.
Yeah, there are some properties of HCF and LCF I'm going to
We are doing the 7 because as it is, means you are reducing the using 7. That's why you are keeping it 7. Means you are just means we are going means 42 is going here, 35 is going there.
Correct,
7 is coming from
dividing.
as divided.
42 divided by 35, remainder is 7.
Sir.
Understood? Do you remember? You must have done it in class 3, 4 division, right?
It was online class.
Online class. Why?
Sir,
COVID.
how we like. Yes, sir, I know, sir.
You know this division?
Yes, sir.
Must have done it in
Yes,
class.
sir.
Okay. Yes. So what happened in COVID? You didn't used to study, right? Online class, playing games and everything behind the screen. Which game you used to play, Aviraj? Tell me. Nothing. From where can I download this nothing game? So anyways, pay attention. The greatest number. Okay, these are some properties. Greatest number.
Nothing is an app of a phone.
Oh, nothing is also a phone.
A phone is.
Sir, it is a phone company.
Phone company. So you used to play in this nothing phone, right? Which will divide A, comma B and C, leaving the same remainders. Leaving the same remainder in each case. Leaving the same remainders in each case. Will be HCF of mod of A minus B, comma mod of B minus C, and mod of C minus A. Okay. For example, the greatest number that will divide the greatest number that will divide 410, 751 and 1030, leaving the same remainder. Leaving the same remainder in each case will be 750 minus 1. We have to take the HCF of 751 minus 410, 1030 minus 751 and 1030 minus 410. Right? Just now we did a problem based on this concept. Do you remember? Just now we have done one problem. Okay. Rest you can understand. If you find it, okay, this will be 341. This will be 279. This will be 620. And when you take the HCF will come out to be 31. Okay, just now we have done a problem based on this. Answer was 97. Next. Largest number that divides X, Y and Z, leaving remainders P, Q and R will be HCF of X minus P, comma Y minus Q, comma Z minus R. Okay. Next. The smallest number which when divided by X, Y and Z, leaving remainders P, Q and R respectively such that X minus P is equal to Y minus Q is equal to Z minus R is equal to K will be LCM of X, Y, Z minus K. Okay, remember. Okay. Next, our next topic is Okay. So last day I have discussed the number of factors of n. Okay. So I'm just writing the sum of all the divisors of n. Okay. If I want to find out the sum of all the divisors, of n. Okay. See, suppose n is equal to p1 to the power alpha 1 into p2 to the power alpha 2 dot into pk to the power alpha k. Okay. Where p1, p2, pk, where p1, p2 dot pk are prime numbers. P1, P2, Pk are prime numbers. Then the sum will be equal to P1 to the power alpha 1 plus 1 minus 1 divided by P1 minus 1. Anyone needs the proof? Let me know. I'll prove it. Multiplied by P2 to the power alpha 2 plus 1. But I think I've already done the proof in our regular classes before. Not with you, but with others. I think I've done it, right? Tell me, Rodit, do you remember? Rodit, Nilanjan, I don't think so. I've done it with you.
No, sir, not with me.
Okay. So I'm just discussing the proof once. Okay, it is very simple.
Sir, can you scroll a little up?
Yes.
Thank you.
Okay. First of all, I'll give an example. Then I'm going to show the proof. Okay. It's very simple.
So the proof is using GP, na?
Yes, proof is using GP. Or there's one
Even
more
I
formula.
remember.
Yes, we have done this in class 10. Do you remember 2 years back?
Yes, sir. I do remember.
See, time flies. Just yesterday you were in class 10, right? Do you remember?
Yes, sir. Yes, sir.
Class 11, 12 will pass like you slept today. You are in class 10. You'll wake up in class 12 directly.
Yes,
Right?
sir. That
So fast.
happened this year.
Yes. Won't even remember what happened in class 11, 12. It is so fast. So study properly up to class 10. Okay. Complete your basics. Anyways, divisors of 2 to the power 7. What are the divisors of 2 to the power 7? 2 to the power 0, 2 to the power 1, 2 square, dot up to 2 to the power 7, right? Okay, if I want to find out the sum of all the divisors, what will it get? What will we get? Sum will be equal to 1 plus 2 square plus dot plus up to 2 to the power 7. Okay, now do you remember x to the power n minus 1 is equal to x minus 1 into x to the power n minus 1 plus x power n minus 2 plus up to x plus 1, right? So instead of x you substitute 2, instead of n you substitute 8. Okay, so what will you get? You will get 2 to the power 8 minus 1 is equal to 2 minus 1 into 2 to the power 7 plus 2 to the power 6 plus 2 to the power 5 plus dot plus 2 plus 1. Okay, so this whole expression is nothing but 2 to the power 8 minus 1 divided by 2 minus 1. Right, tell me. Are you able to visualize this? Aviraj, tell me. Aviraj, Nilanjan, tell me.
Yes, sir, but why are you taking
Yes, sir.
to the power 8? Why are you increasing by 1 power?
Where am I increasing 1
It's
power?
to the power 8 minus 1.
Because if you substitute n equal to 8, then only n minus 1 equal to 7, na?
Oh,
I need the value of this expression.
okay.
Is it clear? Hello, Trishita. Good evening. Can you hear me?
Good evening, sir.
Yes, you joined so late. What happened?
Sir, I told you I had class.
Oh, achha, you had a class. Okay, okay. 2 to the power 8 minus 1 divided by 2 minus 1. Tell me, is it clear to everyone?
Yes, sir.
If you have any doubt, you ask me. I'll explain. Okay, so I think the proof also you understood, right?
Yes.
Similarly, if I talk about p1 to the power alpha 1, Similarly, divisors of p1 to the power alpha 1. What are the divisors? p1 to the power alpha 1 will be equal to 1 p1 p1 square dot 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 up to p1 to the power alpha 1. Right, tell me. Rest you can solve it, right? It will be p1 to the power alpha 1 plus 1 minus 1 upon p1 minus 1. Very simple. Okay. And similarly, I am going to write down the sum of all the divisors. Similarly, sum of all the divisors of p1 to the power, sum of the mth powers, sum of the mth powers of the divisors, mth power of the divisors of n will be equal to, in this case you just multiply by n. It will be p1 to the power m into alpha 1 plus 1 minus 1 divided by p1 to the power m minus 1 multiplied by p2 to the power m into alpha 2 plus 1 minus 1 upon p2 to the power m minus 1. Okay, dot 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 dot, it will go on like this. Is it clear, Aviraj?
Yes.
Tell me. Next, product of all the divisors. Product of all the divisors of n. Okay. For example, if I talk about 12, 12 will be equal to 1. Product of the divisors of 12. Product of the divisors of 12 will be equal to 1 into 2 into 3 into 4 into 6 into 12. If you multiply the first and the last one, you will get 12. Second and second last, 12. Third and third last, you will also get 12. So this is 12 cube. Are you getting, Aviraj?
Oh,
Tell me. This can also be written as 12 to the power 6 by 2. That is number of divisors. 12 has n number of divisors, 6 number of divisors, divided by 2. Are you getting? Because you are pairing them up. But will this happen in perfect squares also? What do you think? No.
Let me imagine.
Imagine.
Sir, yes, sir.
It will happen.
Yes, sir.
Okay. Product of the divisors of, let us say, 36. So what do you think, everyone, those who are online, will it be valid for perfect squares as well? What do you think?
Sir, for perfect square, the number of factors will be odd in number.
Exactly. So what do you think? Will it be valid, Nilanjan?
I don't think so it will be valid.
Okay, let us start. Let us see whether it will be valid or not. Okay. So 1 into 2 into 3 into 4 into 6 into 9 into 12 into 18 into 36, right? So again, let us start pairing them up. Okay, we'll get the pairs 1 into 36. Okay, we'll get the pairs. So we'll get 4 pairs, right? We'll get 36 to the power 4 multiplied by 6. Right, tell me. Now this 6, can I write it as, this 6, can I write it as 36 to the power half? Tell me. When bases are same, powers are added. So it will be 36 to the power 9 by 2. Yes, so it happens. Right, in case of a perfect square, whether you take a perfect square or you don't take a perfect square, it will always happen. Tell me. I hope this is clear to everyone. Next, our next topic is congruences and its properties. Congruences and its properties. Okay. So everyone pay attention from the very beginning, okay? Because those who haven't done congruences with me yet, okay, you need to pay more attention, pay attention properly. If a comma b belongs to integers, okay, Aviraj, if a comma b belongs to integers, And let us say n belongs to positive integers. Why I have taken only positive integers? Because whatever happens for positive integer, like whatever will happen for positive 3, same will happen for negative 3 also. Okay, so I'm just considering positive 3. N belongs to positive integers. Then A is congruent. A is congruent to B modulo n. A is congruent to B modulo n if and only if and only if n divides A minus B. Yes. A is congruent. I mean, we say that A is congruent to B modulo n if and only if n divides A minus B. Means that number n will divide the difference of the numbers. Okay, like today, modulo means mod n. Okay, there are several mod classes of a particular integer. Okay, like 3 has 3 modular classes. One is mod 0, I mean 0 mod, 1 mod 3, and 2 mod 3. Okay, what is 0 mod 3? Means those numbers which are divisible by 3. What is 1 mod 3? Those numbers when you divide it by 3, you will get the remainder as 1. 2 mod 3. 2 mod 3 means those numbers when you divide by 3, you will get the remainder as 2. Understood? Because whenever you divide a number by 3, either you will get 0, 1 or 2 as the remainder. I'll give an example. For example, see, does 5 divides 19 minus 4? What do you think, Aviraj? Does 5 divides 19 minus 4? Yes or no?
Yes, sir.
Quickly tell me what is
Yes,
19
sir.
minus 4?
Sir,
15. This implies 19 is congruent to 4 mod 15. Are you getting? Aviraj, tell me.
yes,
Very simple.
yes.
Okay. So if you have understood, you give me one example.
Sir, 5 divide 5
So can you scroll just a bit?
modulo, 5 modulo 29 minus 4.
What are you saying? Oh,
Five,
okay.
five, what is this? This big
You're
one,
just
sir.
copying my example. Take some other mod.
Okay,
Tell
sir.
me in mod 7.
Mod 7.
Yes, mod 7.
Mod 7, sir.
Over here it should be mod 7. Tell me two numbers such that their difference is divisible by 7. Tell me.
Sir, let me think, sir.
Quickly think.
Mod 7, sir, it should be. It should be, sir.
Quickly.
Yes, sir. Doing that. Sir, I think 28 means, sir, means 5 means 5 divided by 28 minus.
Can I say that 33 is congruent to 19 mod 7? Can I say this?
Yes,
Is 33 minus 19 divisible by 7? Yes or no? No.
yes, yes.
Okay. So from online also I'll take some examples. Yes, Abhijoy, tell me one example.
Yes, sir. 16 congruent to 2 mod 7.
16 congruent to 2 mod 7. Right or not? It's simple only. Just take two numbers such that their difference is divisible by a particular number. Okay, Ahir, you give me one example.
Sir, I'm thinking of, there are so many examples.
So many examples, you just give me one.
17 congruent to 1 mod 4.
17 congruent to 1 mod 4. Next, Arush, you tell me.
So 5 congruent to 3 mod 2.
So simple. 5 congruent to 3 mod 2. Okay. Next, London, tell me.
65 congruent 1 mod 8.
65 congruent to 1 mod 8. But
Yes.
I can also say 65 is congruent to 17 mod 8. Right,
The
same
thing.
thing. Right. Achha, Raudip, you give me with some negative numbers also, okay? Tell me.
Okay, sir. 9 is congruent to -3 mod 6 maybe.
Mod 6, okay. Tishita, you give me one example.
So 9 is congruent to -1 mod 5.
9 is congruent to minus 1 mod 5. Lastly, Venkat, you tell me.
Sir, minus 5 is congruent to 2 mod 7.
Minus 5 is congruent to 2 mod 7. Okay. So see, also you see in these congruences, okay, whatever you divide on the left hand side, like for example, you divide 19 by 15, okay, what is the remainder? Tell me. 4. And you divide 4 by 15, the remainder is 4. 33 by 7, what's the remainder? 19 is the remainder.
33 minus 7 is 9.
I'm asking you something you are telling.
Sir,
In class 2, you must have done division of 33 by 7. 16 is the remainder. Remainder.
Remainder.
I'm asking you remainder. 33 by 7. What is the remainder? Tough sum. See?
Sir, 2.
Ahir, you are also giving wrong answer. 33 by 7. Remainder is 2.
No, sir. I thought 37 by 7.
Oh, 5. Achha. 33 by 7. The remainder is 5. 19 by 7. What is the remainder?
9 by 7 is 5.
5, right?
Sir, class 2 was 10 years back for me.
So you have forgotten everything, right?
Yes, sir.
Okay. So after IOQM is over, I'll start with class 5 entrance exam. Okay. Where I'll be teaching BODMAS rule. Okay. And everything. BODMAS rule, then division. Okay. What else used to come in class 5? I've forgotten. The next 16 divided by
We
7.
haven't learned algebra yet in class 5, sir.
But BODMAS rule was there, I remember.
Yes. Fractions.
Sir, profit and loss.
Profit and loss. Okay. Yes, tell me. 16 divided by 7. What is the remainder? Quickly tell me. Raj, don't play games. 4. 16 divided by 7, the remainder is 2. 2 divided by 7, the remainder is 2. 17 divided by 4, the remainder is 2. 1 divided by 4, the remainder is 2. 5 divided by 2, the remainder is 1. 3 divided by 2, the remainder is 1. Quickly, you have to be quick with calculations, otherwise it will take whole year. 65 divided by 8, the remainder is 1. 17 divided by 8, the remainder is 1. 9 when you divide by 6, the remainder is 3. Minus 3 also when you divide by 6, the remainder will be 3 only. Okay. So what can we conclude? We can conclude that if A and B gives the same remainder, when divided by n, then also we can say A is congruent to B mod n. Are you getting, Aviraj? Tell me. Next. Properties of congruences. Properties of congruences. Okay. Number 1. N divides 0 as well. So I can say n divides A minus A. Right. So we can say that A is congruent to A mod n. Right. Tell me. Number 2. If A is congruent to B mod n, and we say that C is also congruent to D mod n, okay, then you can actually add them. You will get A plus C is congruent to B plus D mod n. Are you getting, Aviraj? Tell me.
Yes.
Next. Number 3. If I say that A is congruent to B mod n, and if you have any doubt in any property, you ask me. I'll explain. B is also congruent to A mod n. I'll explain. Next. Not only A plus C. In second property, I'll extend it. Not only A plus C, A minus C is also congruent to B minus D mod n. You can subtract. Okay. Like in the first sum we saw. Okay. Like that subtraction is also possible. Multiplication is also possible. A multiplied by C is also congruent to B multiplied by D mod n.
Divide is also like this.
But division is not possible. Right. But division is not possible. A divided by D is not, generally it is not congruent to B divided by D mod n.
Is there any exceptions?
Generally. Yes, there are some exceptions, and I'll explain when will it happen. Okay. For example, I'll tell you an example. For example, you see 4 is congruent to 2 mod 2. Can I say? Yes or no?
Yes.
And can I say that 2 is also congruent to 2 mod 2?
Yes.
Right. 2 is also congruent to 2 mod 2. Okay, when you divide, can I say that 2 is congruent to 1 mod 2? Tell me. Is it possible 2 minus 1 is divisible by 2? Tell me. No. Understood? Division is not possible. Number 4. If A is congruent to B mod n, A is congruent to B mod n, and K is a constant, K is a constant, then K plus A is congruent to K plus B mod n. You can add K on both sides. Okay, according to your will, you can add, subtract numbers. Okay, next, K minus A is also congruent to K minus B mod n. Next, Ka is also congruent to Kb mod n. Okay, next, property number 5 is very important. Okay, if A is congruent to B mod n, then A to the power K is also congruent to B to the power K mod n. Okay, you can raise the power by K for some K belongs to positive integers. Okay, for example, see 4 is congruent to minus 5 mod 9. I'm getting 4 is congruent to minus 5 mod 9. So we can say that 4 square is congruent to minus 5 whole square mod 9. Right. You see 4 square is 16. Minus 5 whole square is 25. 16 minus 25 is divisible by 9. Okay. And how will this help us? For example, if I want to find the remainder, when 9 to the power 28 is divided by 7. Okay, I want to find out the remainder when 9 to the power 28 is divided by 7. Okay, Aviraj. So at first what you can do is you can reduce the base. See, 9 is greater than 7. So can I say that 9 is congruent to 2 mod 7? Tell me, Aviraj. This implies 9 to the power 28 is congruent to 2 to the power 28 mod 7. Right, tell me. Now see, the left hand side will give us the same remainder as the right hand side. Right, both the sides will give us the same remainder, right? So now the problem reduces to, finding the remainder. Always reduce the base. Okay, finding the remainder when 2 to the power 28 is divided by 7.
Sir, is answer 2.
Answer is 2, correct. Now my task is to find out such a power of 2 such that you are getting 1 or minus 1 on the right hand side.
2 to the
Why?
power 24.
2 to the power how much?
24.
24. Okay. I have to find out such a power of 2. I want to find out 2 to the power k. I want to find out this k such that it is congruent to either 1 power minus 1 mod 7. Why? Because it is easier to raise the power over 1 or minus 1. Right or not? Means you can find out what is 1 to the power 1000. Yes or no? What is 1 to the power 1000? 1 minus 1 to the power 999? 1.
Sir, what do you do?
Minus 1 to the power 999.
Minus, sir.
Minus 1 to the power 999.
Sir, I can't do it, sir.
You can't do it. Minus 1 to the power 999.
Sir, it will be 1 minus 1.
Minus 1, right? Okay, so I'm saying that it is easier to raise the power over 1 or minus 1. Okay, so that's what I'm saying. You get 1 or minus 1 on the right hand side. You see that 2 cube is congruent to 1 mod 7. 2 cube is 8. 8 is congruent to 1 mod 7, right? So by what we need to raise the power to get close to 28? We can get close to 28, but we cannot get 28 directly. We will raise the power by 9. Right. So what will I get? We'll get 2 to the power 27 is congruent to 1 mod 7. Are you getting Aviraj?
Yes, sir.
Now how much more 2 we need? Only
Sir,
one more
another
2.
2.
So 2 to the power 27 into 2 is congruent to 1 into 2 mod 7. So the remainder is 2. Tell me, is it clear, Aviraj? Okay. Okay, let us do some problems, everyone. Aviraj, if you have any doubt, you can ask me.
Then you are multiplying by 2 and how it is becoming a remainder, sir, because 2 to the power 7, so you are also doing 1 6
Take your time.
Yes, sir. Now understood, sir.
Understood?
So if I like a problem to the formula.
Okay, let's start. Question number 2. Find the remainder. Find the remainder when number 1 7 to the power 38 is divided by 48. Part 2 7 to the power 25 is divided by 4. Part 2. Part 3 3 to the power 45 is divided by 8.
Can you a little bit zoom it, sir? Because zoom the
Questions?
zoom.
Oh, acha, acha. Oh, I understood.
Can do up, sir. Up, what? Sir, up, sir. Before some I want to see, sir.
Okay, okay. Those who are online, keep solving. Let me know the answer.
So
Yes,
we'll see all the 3 parts together.
send. Oh yes, here part 1 and 2 are correct. Yes, Lanjan, part 1 and 2 are correct.
Can you show me the up this examples?
Example, which one?
This one, sir. Just to see, sir.
Okay, here I am checking the third part. Wait, let me see. Dishita, part 1 is correct. Yes, wait, I am checking the third part. Yes, Lanjan, part 3 is correct. Ahir, part 3 is correct. Okay.
So can you show the third part?
Yes.
Sir, are you going to discuss formats today?
Yes. Actually, congruences I'll complete today. After this, I'll discuss one more topic.
So, will you teach CRT? I have been having doubts in CRT since class 10.
CRT, CRT, actually CRT is not required for IOQM. Okay, but still I'll discuss. But today I have planned to discuss base system. Okay, last year two question came from base system. Okay,
Yes, sir.
I remember.
I had also done base system last year, but I forgot.
Okay, we'll discuss base system. CRT also we'll discuss. Okay, Abjoy sent everything. Abjoy, both are correct. Rohdeep, all three are correct.
Can you do the first one?
First one I'm solving. Pay attention, everyone. First one.
Only first one, sir.
Only first one. Okay. See. In the first one, 7 to the power 38 is divided by 48. Okay. Now see, 7 square is 49. Right or not? When you divide 49 by 48, what is the remainder? Tell me.
So, mod 1.
1, right? So can I say that 7 square is congruent to 1 mod? Yes, Tishita, your answer is correct. 48, tell me. Can I say this? Yes or no? Now by what we should raise the power? So that we'll get 1 on the right hand. I mean,
Sir, we should raise the power by 36.
36.
Means 7 to the power 36 we should multiply.
Oh no, why to multiply? We have to find out 38 in the power. So by 2, what should we multiply?
Understood, sir.
19, right?
Yes, sir, 16, 19.
7 square whole to the power 19 is equal to, is congruent to 1 to the power 19, 19 mod 48. Done. This implies 7 to the power 38 is congruent to 1 mod 48. Done. Therefore, the remainder is 1. Done. Is it clear? Tell me.
Yes, sir.
Okay. So try part 2 by yourself. Let's see. Yes, till then, Trishita, your answers are correct. Rohdeep, your answers are correct. Abhijoy, part 3, part 2 are correct. Part 1 is also correct. Okay. Okay, what about Venkat, Arush? You people are not solving.
Sir, sending.
I have also sent, sir.
Yes, just now I have received. Okay, I have received from Arush. Let's see. Yes, Arush. Arush, all three are correct. Venkat, check the second one. Part 1 and 3 are correct. So second one, should I solve?
Just 2 minutes.
2 minutes. Okay, Venkat, can you mute yourself?
So my answer is coming.
Oh, what did you get? Tell me.
So 8. It is the correct answer.
Which one?
So 7, so I'm getting 7 as remainder.
7 is the remainder in case of part 2.
Yes, sir.
But can you ever get a remainder more than 4 in case of part 2? Tell me. In part 2, see, you have got 4. So you see, you must have started with 7 is congruent to 3 mod 4. First of all, you have to reduce the base.
Yes,
Na?
sir, this I give,
So
sir.
7 to the power 25 is congruent to 3 to the power 25 mod 4.
Yes,
Right. Now my task is to find out the remainder when 3 is divisible by 4. Okay. 3 to the power 25 is divisible by 4. Now see, Avraj, 3 square is congruent to 1 mod 4. Right or not? Tell me.
yes, sir.
So by what we should raise the power?
Sir, 7 to this means, sir, 7 to the power 25 is equal to 1 to the power
7. Why are we getting 7 only? Now my task is to find out the remainder when 3 to the power 25 is divided by 4.
So, sir, we should raise the power by 12.
12. We'll get 1 to the power 12 mod 4. Right. This will give us 3 to the power 24 is congruent to 1 mod 4. Right. How many 3s are required? Tell me.
Sir, 1, 3.
1 3 is required. So 3 to the power 25 is congruent to 3 mod 4.
There is also
Therefore remainder is equal to 3.
3.
3 I'm solving, okay. Acha, you tell me how to solve 3.
Sir,
We have got 3 to the power 45 divided by 8. So tell me, 3 to the power something is congruent to 1 or minus 1 mod 8.
Sir, 3 to the power 2 is equal. 3 to the power 2 is equal to 1.
Correct. 3 square is congruent to 1 mod 8. By what we should raise the power for 45?
By, sir, 22.
4 to the power 22 is congruent to 1 to the power 22 mod 8. Right. Therefore, 3 to the power 44 into 3 is congruent to 3 mod 8. Therefore, the remainder is
Sir,
3. Done. Is it clear?
3. Yes, sir.
Tell me. See, sometimes it becomes very difficult to find out 1 or minus 1 on the right hand side. Are you getting? Sometimes it becomes very difficult to find out 1 or minus 1 on the right hand side. So for this reason, there is something called Fermat's little theorem.
What's it?
Fermat's little theorem. So what does Fermat's little theorem says? Pay attention.
Plus we did that.
Pay attention. If P is a prime number, P is a prime number and A belongs to integers such that GCD of A and P is equal to 1. Okay, P is a prime number and A belongs to integers such that GCD of A and P is equal to 1. Then this implies then A to the power P minus 1 is congruent to 1 mod P. Are you getting? Tell me. Like for example, see GCD of 2 and 7 is equal to 1, right? So can I say that 2 to the power 7 minus 1 is congruent to 1 mod 7? Tell me. Can I say this? Yes, we can say. But over here, there is a flaw. Like this Fermat's little theorem is only valid for prime numbers. How? I mean, what shall we do with composite numbers? For composite numbers, we have Euler's phi function.
Euler-Torshan theorem.
Yes.
So can you show a bit more? Like it was just there.
Euler's Torsion function. Okay, or Euler's phi function. Okay, that is phi of n. So first of all, I'm going to define this. What is phi of n? Okay, phi of n. Phi n is the number of positive integers. Number of positive integers less than n and prime to n. Okay, phi of n is the number of positive integers less than n and prime to n. Okay, That is, if I write n is equal to p1 to the power alpha 1 into p2 to the power alpha 2 into dot 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 pk to the power alpha k. Okay. Then phi of n will be equal to n into 1 minus 1 by p1 multiplied by 1 minus 1 by p2 multiplied by dot 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 1 minus 1 by pk. Okay, this is what phi of n is.
Why so confused?
Yes, yes. For example, let us talk about 18. Okay, for example, let n is equal to 18. So, Aviraj, tell me those numbers which are less than 18 and prime to 18. Means they don't have a common factor. Like for example, you see 1. 1 and 18, they don't have a common factor except for 1 itself.
So, sir, 4.
4 and 18, they don't have a common factor.
So 2. Sir, 3 is also 5.
5. Next,
The 7,
7, right?
11, 13,
11.
17.
Done. Right. So what is phi of 18? Therefore, phi of 18 will be equal to how much? 6. Are you getting average? 10. Now, I want to find out phi of. Okay, I want to prove this. Let us see. Okay, let n equal to p1 to the power alpha 1 into p2 to the power alpha 2 dot 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 up to pk to the power alpha k. Okay, let us find out phi of p1 to the power alpha 1. Okay, what is phi of p1 to the power alpha 1? First of all, let us make a set of those integers which are less than p1 to the power alpha 1 but prime to p1 to the power alpha 1. Okay, Achha, let us make those integers. First of all, let us make those integers which are less than p1 to the power alpha 1 but have a common factor with p1 to the power alpha 1. Are you getting? Let us make those integers, positive integers, which are less than p1 to the power alpha 1 but have a common factor with p1 to the power alpha 1. Okay, I'll tell the smallest integer. The smallest one being p1, right? p1 and p1 to the power alpha 1, they definitely have a common factor, right? And next, p2. What is p2?
Say P2 alpha 2.
p2. 2p1, right? 2p1 and p1 to the power alpha 1 also have a common factor. 3p1 and p1 to the power alpha 1 also have a common factor, right? 4p1 and p1 to the power alpha 1 also have a common factor. Like this, it goes on. Up to what term it will go on? It will go on up to p1 to the power alpha 1 minus 1 multiplied by p1. Right? Are you people getting? Those who are online? Tell me. So can
Yes, sir.
someone tell me?
Yes.
Can someone tell me how many integers I have written in this set? Raise your hand. Can someone tell me how many integers I have written in this set? Raise your hand. Tell me. How many integers I have written in this set?
So the last one is P1 to the power alpha 1.
P1 to the power alpha 1 minus 1 into P1.
Oh, acha, okay.
Okay. Right, up to this much, right? These are the numbers which are less than or equal to Pn but prime to Pn. I mean, they have a common factor with Pn.
Yes.
Right. How many elements are there in this set? How many elements I have written? Raise your hand. Tell me. Calculate and tell me. Raise your hand.
So can you see this?
Yes. Tell me. How? Yes, Aviraj. First of all, you tell me.
So this one.
What? Oh, what? How did you get that? Yes. So Ranadeep is raising. Ranadeep, tell me how many terms are there? How many elements are there?
Alpha 1.
Alpha 1? How it is alpha 1? Okay, next, he tell me.
Sir, P1 to the power alpha 1 into 1 minus 1 by P1.
No, not like that. Let's see, everyone. This is 1p1. This is 2p1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to p1 to the power alpha 1 minus 1, right? So the number of terms over here, number of terms will be p1 to the power alpha 1 minus 1, right? Tell me, are people getting? These are the numbers which have a common factor with p1 to the power alpha 1 and less than or equal to p1 to the power alpha 1. So the number of numbers having,
Yes, sir, I actually got confused.
okay, no problem. Raudip, is it clear? Tell me. Having no factor, I mean number of numbers less than p1 to the power alpha 1 and prime to p1 to the power alpha 1. Yes, Avraj, tell me, what are you saying?
How did you found number of terms is equal to P1 alpha 1 minus 1?
This is 1 p1, 2 p1, 3 p1, 4, 5, 6, 7, 8, 9, 10, 11 p1, 12 p1, dot 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 up to p1 to the power alpha 1 minus 1 into p1, na? So there are total how many terms? P1 to the power alpha 1 minus 1. Are you getting? Or should I explain? Okay. Will be equal to p1 to the power alpha 1 minus p1 to the power alpha 1 minus 1. So from here, if you take p1 to the power alpha 1 common, you'll get 1 minus 1 by p1. Done. I hope you people are getting how I have written the whole proof. Now see, how will this help us? Okay, pay attention. How will this help us? If GCD of A and N is equal to 1, okay, then A to the power 5 of N. You can say that this is an extended version of Fermat's Little theorem, because Fermat's Little theorem is also valid. I mean, this theorem is valid for all numbers, okay, not only for prime.
Yes, sir. They
How
just
many
have
to 1?
to be co-prime.
Exactly, they just have to be coprime. Okay. Also, you see, you can derive Fermat's Little theorem from this. I mean, from Euler's theorem only. Okay. You see that if p is a prime number, if p is prime, then what is phi of p? Tell me. What is phi of p? Tell me, everyone.
Sir,
How many numbers are there which are less than p and prime to p?
Sir, P minus 1.
P minus 1.
P minus 1, absolutely correct. Right or not? Tell me, everyone. Now, suppose a belongs to any integer, then a to the power 5 of p is congruent to 1 mod p. Yes or no? Tell me, everyone.
yes,
Can I say this?
yes.
And what is 5 of p? 5 of p is p minus 1. Hence proved. See how we can get Fermat's Little theorem with the help of Euler's torsion function.
Sir, but how did you take sir, A, then A as base, and then 1 more P?
I have used this property. A to the power pi n is congruent to 1 mod n. I have used this property. Is it clear? Tell me, Avraj.
So can you prove this one which you have underlined in red color, sir?
This one,
Yes, sir.
a to the power pi n is congruent to 1 mod n. Okay, so over here we have got okay, over here we have got pi of n in the power. Okay, next. So I'll give you some examples. Pay attention. For example, you talk about 2 and 18. No, not 2 and 18. 5 and 18. What is GCD of 5 and 18? Tell me. What is GCD of 5
So,
and 18? 1. Okay. Now let us take a set of those numbers. Let us take a set of those numbers which are. Achha, let us find out 5 of 18. 5 of 18 is how much? Tell me. 5 of 18 we found it, right? Before. 6. 5 of 18 is equal to 6. Can you understand? Tell me. Achha, so see, is 5 to the power 6 congruent to 1 mod 18? Tell me. Just check. Is 5 to the power 6 congruent to 1 mod 18? Just check. How to check? You see. What is 5 cube? 5 cube is equal to 125. Okay. 125 when you divide it by 18, what are you getting? Divide and tell me what is the remainder. Tell me quickly.
-1.
1. -1. Are you getting? This is congruent to -1 mod 18. Okay. So when you raise the power by 2, we'll get 1 mod 18. Tell me, are you getting? So it will always work. Okay. You can check with some other numbers also. You'll get the same result. Okay. Okay. Everyone, let us try out one problem. Okay. Question number 3. Find the remainder. Find the remainder when 2 to the power 41 is divided by 23. Solve. Okay. You people solve. I'm coming in 1 minute. Okay. You have done this. Quickly send your answers. Question number 4. Prove that 2 to the power 5n plus 3 plus 5 to the power 2n plus 3 is divisible by 7 for all n greater than or equal to 1. N greater than or equal to 1. Okay, I think I'll have to do base system next class only. Okay. After this, I have to do linear congruences. Yes, Rondeep, your answer is correct. Ahir, your answer is correct. Okay, I think I have to start. Okay, Venkat has sent. Trishita, your answer is correct. Yes, Trishita, your answer is correct. Venkat, your answer is correct. Niranjan, your answer is correct. What about others? Others also keep sending your answers. Okay, if you have done this, 3 and 4 you people are solving. Okay, so should I start? Tell me.
Sir, please give us tips, sir.
Tip. Use Fermat's theorem. 23 is a prime number, right? Tell me.
Sir,
Tell me. Show. What have you got? Sit. Huh? The remainder should always be an integer, right? Pay attention. Okay, everyone pay attention. See, 2 to the power 41, we have to divide it by 23, okay? So since 23 is prime, can I say that 2 to the power 22 is congruent to 1 mod 41? Tell me. Right or not? Tell me. Aviraj?
yes, sir.
Sorry. 1 mod 23. Can I say this or not? I need 41 in the power, right? So what I have to do is, I need 19 more 2's, right or not? I need 19 more 2's. Achha, let us reduce the. Achha, so from here, can I say that 23 divides 2 to the power 22 minus 1? Right or not? Can I say this? I think so.
Yes, sir. Yes, sir. Yes, sir.
This implies 23 divides 2 to the power 11 minus 1 or into 2 to the power 11 plus 1. Right, tell me. Okay, 23 will either divide 2 to the power 11 minus 1 or 2 to the power 11 plus 1. Now, this 2 to the power 11 plus 1, okay, wait, let me see. Whether it is 2 to the power 11 plus 1 or 2 to the power 11 minus 1, we have to check. 2 to the power 12, 2 to the power 10, we know it is 1024. We know this, right? And 2 to the power 11 is 2048. Let us divide 2048 by 23. How much are we getting? 2048, when we divide it by 23, what are we getting? 23 times? 23 times? How much? 8, right? How much will it give us? 92 into 2, 184. 184, yes. 184. We'll get 20 over here, 208. Okay. So this will give us 92 into 4, 23 into 8, 23 into 9 will give us how much? 207. Okay. So see, the remainder is how much? 1. Are you getting? So I can say that 2 to the power 11 is congruent to 1 mod 23. Right, tell me. Are you getting? Aviraj?
Yes, sir.
Now Aviraj, by what we should raise our power?
Sir,
To reach 41?
by 2.
By 2?
No, sir, by,
Or by 3?
By 3.
So 2 to the power 11 whole cube is congruent to 1 cube mod 23. Okay, next. So this implies 2 to the power 33 is congruent to 1 mod 23. How much more 2's are required? 8 more 2's, right? 8 more 2's means 2 to the power 8 is 256. Right. So let us divide 256. So in order to do it quickly, you see 2 to the power 5 is congruent to 2 to the power 5 is congruent to 9 mod 23. Right, 32 minus 9 is 23, yes. So we need 3 more 2's, so 2 to the power 8 is congruent to 9, it's a 72. 72 mod 23. Which will give us 2 to the power 8 is congruent to 3 mod 23. Yes. Now you multiply these two congruents. This is 2, this is 1. Multiplying congruents 1 and 2. So this implies 2 to the power 33 into 2 to the power 8 is congruent to 3 into 1, that is 3 mod 23. Done. Tell me, are you getting? Aviraj? If anyone having any doubt, you can ask me. Tell me.
No,
Those
sir.
are online. Clear? Okay. Arush,
Sir, I've
Joy?
said to you question number 4.
Yes, let me see. Okay. So you have broken it totally. Let's see. Yes, you are absolutely correct. Okay, the same way I'm going to do it. So I'm going to solve number 4 as well. Okay, everyone pay attention. 4. See, you can also do it by induction. Your choice. Induction is also possible. Last day I have taught induction. You can apply mathematical induction also and do it. But see, with congruences, how we can prove it. Okay, how we can prove this using congruences. 2 to the power 5n plus 3 plus 5 to the power 2n plus 3. So first of all, break it completely. Okay, can we write it as 8 into 32 to the power n minus 2 cube is 8 minus 5 cube is 125. 125 into, no, 5 cube is 125 into 25 to the power n. 125 into 25 to the power n. This is what we need to prove, everyone. Okay. Okay. Yes. Yes. Lanjan has proved it by induction only.
Induction, yeah.
Yes. Yes. This is what I was saying. He has proved it by induction. Let's also see. We need to prove that this is divisible by 7. So 8 into 32 to the power n. Okay. 8 into 32 to the power n minus 8 into 25 to the power n. Can I say that it is congruent to? Can I say that it is congruent to? Wait a minute. Wait. Actually, you see, 32 to the power n minus 25 to the power n is congruent to 0 mod 7. Yes or no? Tell me, everyone. Can I say this? Because x. Do you remember? I have taught in the class that x to the power n minus y to the power n is divisible by x minus y. Tell me.
Yes.
Arush, Avijoy, Venkat,
Yes, sir. Yes, sir.
Nilanjan, are you getting this method also? Trishita, are you getting?
Yes, sir.
Okay, we know this. Okay, so what I'm going to do is I'm going to add and subtract some terms. That is 8 into 32 to the power n minus 8 into 25 to the power n. Okay, this is divisible by 7. Right or not? Tell me, everyone. This is divisible by 7. I can say that this is congruent to 0 mod 7. Okay, next 8 into 25 to the power n. 8 into 25 to the power n minus 133 into 25 to the power n. This is also congruent to 0 mod 7. Yes or no? Tell me. If you are unable to understand, you ask me, I'll explain. Tell me. No, couldn't understand. Shoaib Akhtar. Right. Bouncer?
Yes, sir.
Yes,
Local bouncers.
Local bouncer, acha. Anyways, you see, what I'm saying is, what is 8 minus 23?
8 minus 20.
125? Acha, I should have written something else. Let me see. Let me see. I need 125 into 25 to the power n, right? I need 125 into 25 to the power n. So 125 into... Wait. I need minus 125 into 25 to the power n. This is plus 125 plus 8 into 25 to the power n. When you subtract, what is 8 minus 133? That is minus 125. No, but that is not divisible by 7. Okay, so this statement is wrong. Okay, I need to modify something. Okay, I need to do some modifications. Let's see. Okay, 8 into 32 to the power n. What do I need? I need addition. Let me see. In the question, what do I need? Yes, I need addition. Okay, it was addition. Okay. Anyways, so 8 into 32 to the power n minus 8 into 25 to the power n is congruent to 0 mod 7. I need 125, right? So 125 into 25 to the power n plus 8 into 25 to the power n. Is it congruent to 0 mod 7? Let me just check. Yes, 125 plus 8 is 133. 133 is divisible by 7. Yes, so this is fine. Have you understood, Aviraj, or not? Now you add these two congruences. Done. Tell me, are you people getting?
So can you explain this step?
Yes. What I am saying is 125 into 25 to the power n plus 8 into 25 to the power n. This will also be divisible by 7. Yes or no? Tell me. Because 125 plus 8 is 133, right? Tell me, Ranadi.
Yes,
If you
sir.
take 133 common, I mean,
It's
basically when you
divisible,
add,
yes.
it is 133 into 25 to the power n. Right, tell me.
Yes, sir.
Okay. Okay, so when you add, these two will get cancelled. You are going to get 8 into 30 to the power n multiplied by plus
Yes.
1 into 125 into 25 to the power n. This will be congruent to 0 mod 7. Done. Hence proved. Tell me, is it clear, Aviraj?
Yes.
Okay, next. So today I'm going to start with linear congruences. Okay. Although I feel that problems may come, may not come. Okay, but RMO it can come. Okay. RMO I have seen problems based on linear congruences. Okay. Linear congruences. So what is a linear congruency, everyone? Pay attention. Suppose f of x equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 plus an, where n is greater than or equal to 1. Okay. Be a polynomial with integer coefficients. Be a polynomial with integer coefficients. Yes, Venkat, you are asking something.
No, sir.
You are unmuted. With integer coefficients. Okay, everyone. A0, A1, A2 up to AN. Okay. A0, A1 up to AN. Okay, provided that A0 is not equal to 0. Provided that A0 is not equal to 0. Okay. Then f of x is congruent to 0 mod n. F of x is congruent to 0 mod n is a polynomial congruence. Of degree n. Okay, everyone, it's a polynomial congruence of degree n. Avraj, are you getting? No. Some you are getting, some are not. Okay. You remember that this is a polynomial, right? It's a polynomial expression.
Yes, sir.
If it is congruent to 0 mod n, then it is known as a polynomial congruence mod n. Okay. Try to understand if it's possible. Okay. So next, if there exists, next point, everyone, if there exists x0 such that f of x0 is congruent to 0 mod n, then we can say that x0 is a solution. X0 is a solution of the congruence. Okay, everyone. Then we say that f0 is the solution of the congruence. Okay. Next, one more thing, everyone. If you find x1 such that x1 is congruent to x0 mod n, if you find x1 such that x1 is congruent to x0 mod n, okay, then f of x1 will also be congruent to 0 mod n. Okay, everyone, you'll get another solution of the same congruence. Okay, this implies x1 is another solution of the congruence. Are you people getting? Yes or no? Another solution of the congruence. Anyone having any doubt, you can ask me. I'll explain. Okay, x1 is also another solution of the congruence. Right, Aviraj, what happened? Not getting anything. Sure. Those who are online, are you people getting? Yes or no?
Yes.
Sir, how can we say that it is divisible by n?
You see, x1 is congruent to x0 mod n. Okay, from here, can I say that f of x1 is congruent to f of x0 mod n? Tell me, can I say this? Yes or no?
So yes, sir. I'm talking about like considering the function divisible by n.
This function? Oh, means you are talking
Yes,
that
sir.
how can the function be divisible by n?
Yes, sir.
Because all these are integer coefficients, right? Tell me. All these are integer
Yes,
coefficients. So you might find some value of x, some integral value of x, such that this f of x naught will also be an integer. Okay, and it might be divisible by
yes,
n. Are you getting? So that's why in the beginning only, in
yes.
the
If it
beginning
is a
only.
solution, then
Yes, tell me, you are saying something.
no, sir. I was confused. Nothing, sir.
Okay, now is it clear, or should I explain? Tell me.
Yes, it's clear.
Okay. Others, tell me, Nilanjan, Raudhi, Venkat, and
Um,
Tishita. People getting? If you are not getting, let me know. I'll explain again.
so getting, sir.
Yes,
Abijoy?
sir.
Getting,
Getting.
sir.
Yes.
Yes, sir.
Yes, what is this f by x?
What f?
Suppose f uh,
F bracket x.
yes,
Okay, it's a polynomial. Okay, f of x. This is how we denote a polynomial, f of x. Understood? Okay, and why do we denote like this? See, f of x works like a machine. Okay, where x is the input and f of x is the output. Understood? For example, f of x equal to x square plus 1. Okay, so x square plus 1 is the machine, but x is the input that you are giving it to the machine. For example, what if f of x equal to x square plus 1? What is f of 1?
answer what's the
If f of x equals to x square plus 1, what is f of 1? Tell me, Aviraj.
f of 1 should be also 1 square plus 1.
2. So are you getting? That is the output. Understood why do we denote it like f of x? Okay. Next, everyone, let us continue. F of x1 is congruent to f of x0 mod n. Okay. So similarly, you can find out infinitely many solutions for a congruence. Okay. Thus, everyone, thus, if one solution is found, if one solution is found, if you are finding one solution, okay, then there will be infinitely many solutions. Then there will be infinitely many solutions. Infinitely many solutions of belonging to same, yes, x0 mod n. Okay, everyone, in the same class as x0. Okay, Achha, two solutions x1 comma x2 of f of x congruent to 0 mod n are said to be distinct. Two solutions x1 x2 of f of x is congruent to 0 mod n are said to be distinct if x1 is not congruent to x2 mod n. Okay, then only you can say that they are distinct solutions. Okay, therefore, okay, therefore the number of solutions of a congruence mod n, therefore, achha, by just add by, okay, everyone, by the number of solutions of congruence mod n, okay, we always mean we always mean the number of solutions incongruent in pairs. Okay, everyone, means I'm telling you what what does this statement means, you will understand. Incongruent in pairs. Pay attention, everyone. I'm telling you what is the meaning. Okay. Means over here you see, suppose you found out a solution. You found out a solution that x0 is congruent to 0 mod n. Okay, you have found out a solution that x0 is congruent to 0 mod n. You have found out a solution x1 is congruent to 0 mod n. Oh, okay. And you have found out you have found out that x1 is congruent to x0 mod n. Okay. Then both x1 and x0, they are the same solution because they are congruent to each other. They are the same solution. Okay. But when we if we found out x2 is congruent to 0 mod n such that x2 is not congruent to x1 mod n. Okay, and x2 and x1, they don't belong to the same modulo class. Okay, then we say that x1 and x2 are different pairs. Means there will be two solutions of the congruence. Are you people getting what is the meaning? What is the meaning of different solutions? Tell me, Ronald, you are asking something.
Sir, what does different classes mean? I mean,
Different classes means they will give us different remainders when divided by n.
okay.
Understood? I'll give you an
Yes.
example. For example, let us say you have got x square is congruent to 1 mod 8. Okay. For example, you have got x square is congruent to 1 mod 8. Okay. Ramadi. Aviraj, are you getting? No.
Sir,
I'm just giving an example. You understand this. Okay. X square is congruent to 1 mod 8. Okay. So over here, x equal to 1 is a solution of the congruence, right, everyone? Is a solution. Of the congruence. X equal to 1 is a solution of the congruence. Okay. So I can say x equal to 8k plus 1 is a solution of this congruence. Okay. Is a solution of this congruence. Okay, everyone. X equal to 1 is a solution of this congruence. Okay. But everyone, over here, is x equal to 3 also a solution? Tell me, what do you think? Substitute x equal to 3. Is x equal to 3 also a solution? Yes or no? Tell me.
Yes, sir.
X equal to 3
Yes,
is also a
sir.
solution. Are you getting Ronaldip? And what do you think? Is 3 congruent to 1 mod 8? What do you think?
No, sir. So there are
No, sir.
different classes.
They belong to different classes. Okay. So over here 1 and 3 are distinct solutions. Are you getting everyone? What do you mean by distinct solutions? In case of congruences. Similarly, you will find out x equal to 5 and x equal to 7 are also the solutions. Similarly, x equal to 5, 7 are also solutions. Are also solutions of this congruence. Okay. See, this linear congruence is also important to understand some other topics which are there in ISI. Okay. You are giving ISI's entrance when you go to class 12. Okay. These are very important. Yes, you ask.
yes, sir, fx and how is becoming sir x1, so that's this man.
fx is not becoming x1. X1 is an input. Okay. X1 is an input. So I wrote x1 in place of x. Understood? Like just like I wrote 2 in place of x before when I asked you. Okay, next. So over here, how many solutions does it has? Over here there are 4 distinct solutions. 4 distinct solutions of x square is congruent to 1 mod 8. Tell me, are people getting, anyone having any doubt, you can ask me. Okay. And there cannot be more than 8 modulo, there cannot be more than 8 solutions of this congruence, okay. Maximum we will get 8 only over here. Okay, I think we can do one problem based on this. Let's see. Okay. Okay, you people try this out. Okay. Question number 1. Achha, how to solve? First of all, I am giving you an example. Then you people try. Okay. For example, solve the linear congruence. Solve the linear congruence. 5x is congruent to 3 mod 11. Okay, everyone. I want to solve the linear congruence. 5x is congruent to 3 mod 11. Okay, everyone. Pay attention. So, everyone, from here, can I say that 11 divides 5x minus 3? Tell me. Can I say this? Yes or no? 11 divides 5x minus 3. This implies 5x minus 3 must be equal to some 11 into minus b. Why I am taking minus b? Because I have to take minus b to the left hand side. Okay, so from here we'll get 5x plus 11b is equal to 3. Okay, so everyone, what is the GCD of 5 and 11? Tell me.
1.
1. This implies there exist some integers. Some integers x and v. Sorry. U and I should have written as y. Okay, so that I can use uv later. Okay, u and v such that 5u plus 11v is equal to 3. Right, tell me everyone. Can I say this? Sorry, not 3, 1. 5u plus 11v is equal to 1. Okay, everyone? So everyone, let us take it as y only. Okay, it will be easier for me to compare. Okay, 5x minus 3 is equal to 11y. So 5x minus 11y equal to 3. Okay. Now everyone, let us find out u and v. How to find out? We'll use division algorithm. 11 is equal to 5 into 1 plus 6. Or you can do hit and trial also. What are the values of u and v we can take? U equal to 2, v equal to u equal to minus 2, v equal to 1, I guess. Yes or no? Tell me everyone.
Yes.
Will satisfy? So I'll get 5 into minus 2 plus 11 into v is equal to 1. Yes or no? Tell me everyone. Okay. But see, in order to compare these two equations, I need to multiply by 3 on both sides. So I'll get 5 into minus 6, 11 into 1 plus 11 into 3 is equal to 1 is equal to 3. Right, everyone. So what are we getting? 5 into minus 6 minus 3 is equal to 11 into 3. Right, everyone. So from here, what do we get? 5 into minus 6 is
So would it
congruent
be
to...
minus of 11 into 3?
Okay, so I'm writing 11 into minus 3.
Yes.
Is congruent to 11. Is congruent to 3 mod 11? Yes or no? Tell me everyone. This was the congruence. Yes or no? Tell me. 5 into minus 6 is congruent to 3 mod 11? No, why minus 3? Why minus 3? See, what I have written, a minus b is congruent to, a minus b is equal to 11k, right? That means a minus b is divisible by 11, na? So I can say that 5 into minus 6 is congruent to 3 mod 11. So what does it implies? It implies that x is congruent to minus 6 mod 11. Tell me, those who are online, are you people getting yes or no? So this implies x is congruent to 5 mod 11 is the solution. Tell me, those who are online, are you people getting? Rahadeep, Abhijoy,
Yes, sir.
Nilanjan, Ahir, are people getting?
Yes,
Yes, sir.
sir.
Yes, sir.
Sista and Venkat?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, but there is a less chance that it will come in PRMO. Okay, I mean IOQM. It might come in RMO. Okay, for RMO it is important. Linear congruences, Chinese remainder theorem. For RMO it is important, but not for IOQM. IOQM it's not that important. Okay, it might not come, but still, you people may be the lucky ones who might get a linear problem on linear congruence. Okay, so let us do one problem on linear congruence. Okay, everyone. I'll give you an easy one. Let us solve. Okay, try this out. One last problem for today, everyone. Next class, I'll complete this chapter. If I find some time, I'll discuss. I'll start with theory of equations. Question number, what is it? 4 or 5? Question number 5. One last problem. Try it out. Okay. Solve the congruence. Solve the linear congruence. Four x is congruent to 3 mod 5. Solve. So just follow the same steps, you'll get the result.
Can you please show me the examples?
Example, yes.
So you can scroll a bit up. I mean,
Yes.
down. Yes.
Okay, should I start? Tell me. 4x is congruent to 3 mod 5. Let us start.
Sir, just 1 second, sir.
1 second is over. Radhi,
Yes, sir. Should I tell the answer or should I send you?
I know, send. Quickly send. Others are also solving. Just follow the similar kind of steps.
So can you little bit up, sir, again? So I have just complicated, sir. Just up, sir. Yes, sir.
Present.
Yes, Ramadip, your answer is correct. Okay, let me start.
Sir, this just
Okay, sorry. Yes. Here also your answer is correct.
Sir, will you be taking the limits and differentiability test next week?
So next week. LCD test is next week. I didn't put up the message, right?
Sir, can you take it like the week after next week? Because next week I will have an offline exam on Sunday.
Oh. Then you give it offline. I mean, you give it on the week after. Okay. Let others
Yes, sir.
give
I
give on.
will give it offline.
Means you give it after that week. Okay. Others will give it next week only. Okay.
Okay, sir.
No. Actually, you have to find out the value of x. Okay. See. So everyone, let us start. I want to find out 4x is congruent to 3 mod 5. Pay attention. So same thing. Okay. I'm writing it directly. 4x minus 5y must be equal to 3k. Okay, that means 3 must divide 4x minus 5y. Oh, wait a minute. 4x minus 3y is equal to 5k. 4x minus 3 should be equal to 5k. Okay. So that means 5 should divide 4x minus 3. Okay. Or you can say 4x minus 5k equal to 3. Okay. So what is it? Since GCD of 4 and 5 is equal to 1. Okay. There exists some integers u and v such that 4u minus 5v is equal to 4u plus 5v equal to 1. So it's very simple, right, to find out u and v. U is equal to minus 1, v equal to 1. Okay, this implies 4 into minus 1 plus 5 into 1 is equal to 1. Right, Abhijoy, are you getting? Abhijoy, Arush, Venkat, Tishita, Nilanjan,
Yes, sir.
are the people getting?
Yes, sir.
Yeah, but
Yes,
what we should
sir. Yes.
multiply? We should multiply by 3. We'll get 4 into minus 3 plus 5 into 3 is equal to 3. So from here we are getting that 4 into minus 3 is congruent to 0 mod 5. Right, it is divisible by 5. Okay, so I can say that x is congruent to minus 3 mod 5. Now we need to add 5 on both sides. This implies x is congruent to 2 mod 5. Done. This is the solution. Minus 3 mod 5, we need to add 5 on the right hand side to make it positive. Tell me, those who are online, is it clear? I hope it is clear to you.
Yes, sir.
Okay. Achha, by the end of June, okay, currently it's 5th June, not by the end, by the end. By the end of, achha, when is IOQM test? I mean, exam is in September, right?
6th September.
6 September.
So June, July, August. So by the end of June, I'm taking number theory test. Okay, full number theory. Okay, IOQM pattern. Okay, is it clear? End of June, IOQM pattern. 2 into 10, 3 into 10, 5 into 10. Okay, based on number theory. Okay. So keep practicing.
So
Okay.
from the challenge page, sir.
So will it be a 3-hour test?
Let me see what kind of paper I have. Based on that, I'm saying. Okay. Just give me 1 minute. Okay. Just check what paper I have. Just wait. Just in 1 minute. Yes. Let me see. Number theory. Where? To keep it properly. I have it. It is number theory only, I guess. Okay. Currently, why I'm not getting the paper? Mock test. Okay, I think I've got it. I'm telling you. It's 10 into 2. Yes, 180 minutes, 3-hour paper. Okay. So it will take time. Oh, how will you give it on Sunday then? Okay, it's a 3-hour paper.
So you have classes after.
No, so you can, if you can sit for 5 hours, I don't have a problem.
Sir,
Okay.
I can.
Yes, then it's fine. Okay.
Sir, my
Okay.
entire weekend is blocked.
It is wrong. So 3 hour slot.
From morning to night.
Yes, so that's why I'm keeping flexible time. Okay. It's flexible,
Yes,
but
yes.
give it offline. Okay.
Yes,
Okay.
sir,
So
I'll give it.
I think we can keep it till now. Next class we'll again continue. Thank you everyone.
Sir,
Good
sir,
night.
sir, I have a
Thank you,
doubt.
sir.
Could you solve one question, like on Euler's torsion function?
Or the torsion function. Yes, send it once.
Sir, the question is, what is the remainder when 29 to the power 29 to the power 29 is divided by 9?
2. That day we
2.
solved.
No, you didn't solve it. You were saying it was 2, but you didn't
Acha, but
solve it.
some other. Acha, wait. Some other answer was coming.
Yes.
Acha, let me solve then. Let me solve. It was 29 to the power 29 to the power 29 divided
29.
by.
9.
I understood. Divided by 9, right?
Yes.
Let's see. So it is equivalent to finding the remainder when 2 to the power 29 to the power 29 is divided by
Yes.
9, right? Okay.
Yes. Yes.
I didn't solve it. I just said that it is 2. Okay.
Yes. Yeah.
Let's see. Okay. So by what we have to start? We have to start with 2 cube. 2 cube is congruent to minus 1 mod 9. Right. Tell me, Nilanjan.
Yes. Yes.
Okay. Now we need to raise the power by something so that we can get close to 29 to the power 29, but not exactly 29 to the power 29, right?
2 to the
So
power
let
27 is congruent to minus 1.
no, not like this. No. 2 to the power 3 whole to the power k, right?
Oh,
Tell me.
yes.
Where 3k is very close to 29 to the power 29, not exactly 29 to the power 29. Is congruent to minus 1 whole to the power k mod 9. Right, tell me.
Yes, sir.
But I need to understand that this 3k, I mean how much close we are with 29 to the power 29. Okay? So let
Yes.
us divide 29 to the power 29 by 3. 29 is congruent to minus 1 mod 3. Right, tell me.
Yes, sir.
This implies 29 to the power 29 is congruent to uh,
Minus 1.
minus 1 mod 3 only.
Yes.
This implies 29 to the power 29 is of the form 3k minus 1, right? No, 3k minus 1. Or you can say 3k plus 2. Right, tell me.
Yes, sir.
Okay. Now we need to understand whether k is odd or even. That only will decide the right hand side, na? So tell me, k is odd or even?
Yes. Is
By looking at
odd.
this,
Odd.
k is odd or even? What do you think?
Is odd.
If k
I
is odd, then 3k will be odd. Odd plus 2 will
Yes,
be odd, so
yes,
k
yes,
has to
yeah,
be
yeah,
odd.
yeah.
So this will be
Yeah.
congruent to minus 1 mod 9. Tell me, is it clear?
Yes.
By what we should raise the power? 2 square, right? We need 2 more 2's.
Yes.
Oh yes, the answer is coming as 5. Yes, yes.
Yes, that only.
Okay, okay,
And
okay.
5 is not in the option.
5 is not in the option. Okay. Okay, okay. Then I'll rectify this. Wait for some time.
You can rectify it in the class then in Sunday.
No. In the test portal only I'll rectify it.
Okay,
Okay.
okay. Okay, sir.
So that you will get the marks over there. Let's see.
Mhm. Thank
Okay,
you, sir.
okay. Yes. Okay. So thank you everyone. Good night. Yes.
Yes, sir.
Sir, I will send you some questions. Can you just check my method? Like, there's some ambiguity in my methods, I feel.